Hello there! This lecture is going to show you how to display data that's collected over time, or time series data, and you're going to be using frequency distribution tables, but with data collected over time, and also line charts and ogives if you're looking at cumulative increases or decreases in values across time. So in this lecture, I will show you what a cumulative relative frequency distribution table looks like, and then how that can be used to create a line chart or an ogive, and then also looking at how to display the frequencies for two variables that are measured across time. So at first glance, this table may be somewhat overwhelming, but I'm going to break it down for you so that you can understand how all these values came to be. So this is data looking at the number of iPads sold each day this week. So you'll see that our days are displayed here in order, and you'll see that here we have the frequency or the number of iPads sold on each day. So for instance, we didn't sell any on Monday, but on Sunday we sold 5. So just looking at that, that's pretty basic. You can also see that if you add up all of the frequencies, you're going to get the total number of iPads sold across the entire week. So on Monday through Sunday, we sold a total of 19 iPads, and you can see how that's distributed throughout the days of the week. Now let's move on to the relative frequency, or the percentages, and this should be a refresher for you. You've already seen stuff like this before. So if we look at this, we'd say, okay, well, there's 19 iPads total, and on Monday, we sold 0 out of 19 iPads, times 100 is 0%. But on Tuesday, we sold 2 out of our 19 total iPads, bringing us to 10.53%. On Wednesday, same exact thing, because we sold 2 out of 19 iPads, so you'll see this looks exactly the same as what's above it. Then on Thursday, that's where we sold 3 out of our 19 iPads, same on Friday, so you'll see these look the same. Then on Saturday, we sold 4 out of 19 iPads, and Sunday, we sold 5 out of 19 iPads, so 21.05% and 26.32% respectively. Now, as always, when you are creating percentages of a whole, you're going to expect that if you add all of those percentages together, you are going to get something that's around 100%. So if you were doing this by hand and you wanted to check your math, you could make sure that all of these things add up to something really close to 100%. Now let's take a look at the last column here. So let's say that instead of just looking at the percentage of total iPads or the frequency of iPads sold per day, you wanted to see how the number of iPads increased throughout the week. So a cumulative increase in sales. So to do that, if you did this by hand, and I'll show you how to do this in Excel in a separate video, you start off, so this will be your cumulative relative frequency, or your percentile. And you'll start off with the first value, or the earliest day, for instance, in this case. And you just take that percent and copy it over. Then for the next one, you're going to say, okay, well, I need to take the percent sold the day before this day, which now we're looking at Tuesday, and add that to the percent sold on this day. So you end up with 10.53%. And what the cumulative percent really tells you is it tells you what percentage of all the iPads sold were sold this day or before. So cumulative percents tell you the percent of whatever you're looking at that happened at or before the day you're looking at. Now, if you were doing this with non-time series data, you would just say that this is the percent of this value or lower. But here it's now, this is the percent of sales of this day or before. That's how cumulative percents work. So with that in mind, let's go to the next one. So if we're trying to figure out the cumulative percent of iPads sold this week on Wednesday, we're going to take the cumulative percent for Tuesday, add it to the percent for Wednesday to get this. And then when we go down, we're going to take this percent, add this percent to get this, and then this percent plus this percent to get this, and then this percent plus this percent to get this, and then this percent plus this percent to get this. So you're just kind of gradually adding it up as you go along to end up with 100%. So whatever you got here should be the same thing that you end up with here. If not, then something has gone horribly wrong with your table construction. So if we look at this, it makes sense that this would be 100%, right? Because the cumulative percent tells you the percentage of sales that occurred that day or before. And since Sunday is the last day of the week, all of our sales occurred Sunday or before of this week. So now here's a cleaned up version of that table. And as I've said before, you would never display all that math in a table if you were presenting your findings to a research group or in a board meeting or to your team members or whatever you're doing with that data. You wouldn't show the math. You would show this version of the table that's nice and clean and has all the values already there. But with this table, we can answer quite a few questions about our data. So let's start with one. So what percentage of the week's iPad sales happened on Saturday versus Sunday? So here you could see that pretty easily. And it's nice, if you're wanting to make projections about the sales that you're going to have on any day of the week, you'd probably focus on these percentages because, maybe you are selling more, maybe it's Christmas time, right? So these numbers are going to be higher, but you can make those projections based on these percentages because it'd be the percentage of those higher sales. So I just want to point that out for you. So let's look at another question that we can answer. What percentage of the week's iPad sales happened before the weekend or on or before Friday? So think about that. Where would we need to look to find that? We would need to look at our cumulative percentage, right? Because we're looking at the percentage of sales that happened this day or before. So that's going to come straight from those cumulative percentages. So before the weekend, we sold a little more than half of all the iPads that we sold for the week. Now let's see, what percentage of the week's iPad sales happened during the weekend or after Friday? So now we're really looking here. So this is not a cumulative percent because cumulative percents are relative to at or before. This is after. But we can use those cumulative percentages to get the values that we want because we know that we end with 100%. And 100% minus all the sales that happened before are going to leave you with the sales that happened after. You could also opt for just adding these two percentages together and you end up with the same value of 47.37%. So far, I've only shown you the overall frequency distribution table that has both your raw frequencies and your relative frequencies, and then also your cumulative frequencies across time. So the percentage that's at or before that particular day. So now let's move to converting those into the appropriate graph to display that data. So if you're more interested in fluctuations across time, then you would want to use the frequency or the relative frequency, right, the percent, and you would want to display that in a line graph. So again, if you're looking at fluctuations across time, a line graph is the way to go. And typically those line graphs tend to be kind of all over the place, right? There's changes over time. If you are more interested in the ever-increasing or decreasing total, the overall cumulative total of something across time, then you would calculate a cumulative frequency, and you would display that on an ogive, not ogives, ogives. And typically those are negatively skewed, where you see the values increasing over time. You're not going to see peaks and valleys here. It's either going to be a nice smooth downward or a nice smooth upward because it's cumulative. If you have a cumulative decrease, it's going to be downward. Cumulative increase, it's going to be upward. Again, you're not going to have those peaks and valleys because you're adding the percentages over time. Now remember, on the previous slide, I said that if you want to look at fluctuations or differences across time, then a line graph is the best way to go. So you'll see that here. You'll see that the height of where the line kind of stops above the day corresponds to the frequency or the number of iPads. So for instance, Monday, 0, Tuesday, 2, all the way up to Sunday where we sold 5 iPads, and you'll see that there. You'll also notice that it kind of goes up and down, right? It's not a continuous increase or decrease across time because we're just looking at each day in its own right. We're looking at the frequency for that day. Now, it's important to note that if we turn these into percentages, it would look roughly the same. Now, I also want to point out that these frequencies could technically be displayed in a bar chart because day of the week is ordinal. But a line graph is typically more appropriate if you wish to examine changes over time because a line denotes time and bars typically represent different categories. So you've seen bar charts before. You could technically display this if you just wanted to look at each day individually, but if you really wanted to look at changes across time, a line graph is ideal. So now you can see that we've taken the cumulative relative number of iPads sold and used that to create an ogive. And here you'll see that the ogive shows the cumulative increase across time. So the rate of change you can see increased on the weekend, but you can't really see the differences in sales across time. You can just kind of see the cumulative change in sales. So this is really only appropriate for variables with frequencies that can be added up over time, not for frequencies within separate, unrelated units of time. So for instance, if you were wanting to look at the number of students born each month of the year, that would require a bar chart. So each month of the year would be ordinal, and you would do a bar chart there. Because you're not really looking at changes across time, you're looking at frequencies for each time period. Also, you'll notice that this ogive doesn't have any dips or peaks. It's going to be a consistent, smooth increase or decrease, but typically an increase. And you'll also see, just as before, Monday, 0. When we get all the way up to Saturday, that sits right about the 73.68%. And then finally Sunday, that's 100% of all the sales for the week are completed on Sunday. So now I want to show you an alternative way that you could look at cumulative frequencies across time instead of percentages, and also an alternate way that you could compute the cumulative relative frequencies across time. So the first one I showed you, we didn't have this cumulative frequency of iPads sold. We had the relative frequency or the percentages, and then we used those to generate these. But in this one, I have the cumulative frequency of iPads sold. So we start off with 0 on Monday. And remember, cumulative means at or before. So that means we sold 0 Monday or before, because there is no before. We didn't sell any on Monday. Then we take this 0 plus 2. We sold 2 Tuesday or before. Take this 2, add this 2. We sold 4 Wednesday or before. Take this 4, add this 3, and we sold 7 Thursday or before. Take this 7, add this 3, we sold 10 Friday or before. And again, take this 10, add the 4, we sold 14 at Saturday or before Saturday. And then take this 14, add it to 5, and we sold 19 Sunday or before, which corresponds to the total number of iPads sold in the week because Sunday is the last day of the week. So now that you've got those frequencies, you can use those to then convert into the relative frequency for the cumulative totals. And instead of adding percentages, now you're going to say, okay, 0 out of 19. 0 out of 19. Divide that, multiply by 100. You get 0%. Then for the next one, you take this 2 divided by 19. You get 10.53%. And for the next one, 4 divided by 19. And you see the pattern there. And you finally end with 19 divided by 19 for 100% of all the sales for the week. So I showed you this because now I'm going to show you the way that you could display this in an ogive where you have the frequencies instead of the percentages. And sometimes that's more useful because, of course, the last day of your data collection, you're going to have 100% at the top. That's not very revealing. But what you may want to know is how many iPads you sold in total. How many, not the percentage of sales. So now let's take a look at these two different ogives. This one is based on cumulative relative frequencies, or the percentage increase across time, whereas this one is based on the frequencies. And as I noted before, this one may be more useful because you want to know overall, total, how many iPads you sold. And that's right here. If you look at this, that's right between 18 and 20, so that would tell you 19. Notice that the lines in these two ogives look exactly the same. It's just here you've got the percentages along the axis, and here you have the actual frequencies. So it depends on the nature of the questions that you're trying to answer, but typically I opt for this version right here where you're looking at the frequencies across time and not necessarily the percentages, because again, you're always, if you have an increase, you're always going to end on 100% in an ogive. So now let's shift our focus to a situation where you've collected data on two variables across time. So here you'll see not only are we looking at the number of iPads sold over the course of the week, but we're also looking at the number of geniuses on duty each day of the week. So maybe the manager at the Apple Store wants to see if having more geniuses is related to selling more iPads over the course of the week. Or maybe the manager at the Apple Store wants to see if they are staffing enough geniuses to keep up with the demand for customers who need help setting up their new iPads. Now you could technically do a scatter diagram, which would reveal actually a strong positive relationship, but line graphs are more appropriate for time series data, where you're collecting data across time to look at trends across time. Now this graph right here really makes it look like there's not much of a relationship, and it suggests that there's always far more geniuses on staff than iPads being sold each day. But take a minute to look at the range of values here and the range of values here, and think about why this particular graph and that interpretation that there's not much of a relationship could be problematic. So in the previous slide, I asked you to think about some of the problems with that graph and the fact that we only use the range for one variable for our y-axis. So if you think about the previous graph, we were really basing that on kind of the range regarding number of geniuses. That underestimated the fluctuation in iPad sales because those numbers were so large, and overall these numbers are smaller. So if you have a situation where you're wanting to look at changes across time for two variables, but they have very different numbers associated with them, it's better to have two y-axes, one that's relevant for each variable's range. So you'll see in this line graph, this y-axis presents a reasonable range of values for the number of iPads sold, and this y-axis provides a reasonable range of values for the number of geniuses on duty. So this graph is different than the previous because there's those two sets of y-axes that represent an appropriate scale of frequencies. Again, the left side represents the frequencies for iPads, a smaller range, and then the right side represents the frequencies for geniuses, which is on a larger range. So now with this graph, you can see that having more geniuses is related to selling more iPads over the course of the week, and that they are staffing at levels comparable to changes in iPad sales over the course of the week. This graph really makes it look like there is a relationship between how many geniuses are on staff and the number of iPads sold. And this graph, again, is nice because it represents the fluctuation in iPad sales because the frequency metric for iPads is based on small numbers, and that's more appropriate for the number of iPads that were sold throughout the week. So this would be, again, an ideal way to display your data if you were looking at changes across time and frequencies for two variables where they have very different ranges in terms of frequencies. So here's that awesome table again that kind of summarizes all of the different ways to display data based on the nature of data. And you'll see that based on this lecture, we're looking down here, where if you have variables that are measured across time, where you're looking at cumulative increases or decreases, you're going to want to base your values on cumulative relative frequencies or just cumulative frequencies if you're just looking at the number, not the percent, and you would plot those in an ogive. Where if you're looking at variables measured across time and you just want to look at fluctuations, but you're not looking at cumulative increases or decreases, you could just use a regular old frequency distribution table and you could display those in a line chart or line graph.